Heat pump sizes are indeed characterized by their tonnage rating. 1 ton of cooling capacity is defined as the amount of cooling required to remove 12,000 British thermal units, or BTUs, of heat per hour. Now, concerning the amperage rating for a 4-ton heat pump, this depends on the specific model and the manufacturer. However, a typical amperage range for a 4-ton heat pump falls between 20 and 30 amps. Residential heat pump tonnage ratings typically range from 1 ton to 5 tons. If you only know that a furnace will be installed but don't know the size of the heat pump that will be connected to it, you can still determine the appropriate circuit conductor size. Firstly, check the furnace's electrical requirements. Determine the maximum amperage draw of the furnace. Secondly, use a higher amperage rating. Select a circuit conductor size that is rated for an amperage higher than the furnace's maximum draw. For example, if the furnace draws 30 amps, you could use a circuit conductor rated for 40 amps. Thirdly, consider future upgrades. If there is a possibility that a larger heat pump may be added in the future, you can select a circuit conductor size that can accommodate this larger unit. For example, if you think a 4-ton heat pump may be installed in the future, you could select a circuit conductor rated for 40 amps. Always consult with a qualified electrician or heating, ventilation, and air conditioning technician to ensure that the correct circuit conductor size is used. When sizing conductors for heat pumps, several factors must be considered to ensure safe and efficient operation. The National Electrical Code, or NEC, provides guidelines for conductor sizing based on the equipment's electrical characteristics. The rated load current, often referred to as the full load amps, or FLAW, is the current the heat pump is expected to draw under normal operating conditions. This information is typically found on the unit's nameplate. The minimum circuit ampacity, or MACA, is the minimum allowable ampacity for the conductors supplying the heat pump. The MCA is calculated by multiplying the rated load current by a factor, typically 1.25, to account for continuous operation. This calculation ensures that the conductors are sized to handle the continuous load without overheating. For example, if a heat pump has a rated load current of 20 amps, the minimum circuit ampacity would be 20 amps multiplied by 1.25, which equals 25 amps. Therefore, the conductors must be sized to carry at least 25 amps. The overcurrent protection device, such as a circuit breaker or fuse, protects the conductors and equipment from overloads and short circuits. The size of the overcurrent protection device is determined by the equipment's maximum overcurrent protection, or MOP, rating, which is also found in the unit's nameplate. The overcurrent protection device should not exceed the MOP rating. In some cases, the NEC allows the use of the NEC standard overcurrent protection device size if the MOP rating does not correspond to a standard size. For example, if a heat pump has a MOP rating of 35 amps, a 40 amp circuit breaker may be used if a 35 amp breaker is not readily available. Conductor size is determined based on the minimum circuit ampacity and the allowable ampacity of the conductor. The NEC provides tables, such as Table 310.15, B16, that list the allowable ampacities of various conductor sizes based on their insulation type and ambient temperature. The conductor must be sized so that its allowable ampacity is equal to or greater than the minimum circuit ampacity. For example, if the minimum circuit ampacity is 25 amps, a 12 American wire gauge, or AUG, copper conductor with THHN insulation, which has an allowable ampacity of 30 amps at 75 degrees Celsius, may be used. Voltage drop is the reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, conductors should be sized larger than the minimum required by the ampacity tables. The length of the conductor run and the expected load current are factors in calculating voltage drop. The further away the electrical panel is from the heat pump, the more important it is to select the right wire size to avoid issues. Ambient temperature affects the ampacity of conductors. Higher ambient temperatures reduce the allowable ampacity of conductors, while lower ambient temperatures increase it. The NEC requires that conductors be corrected for ambient temperature using correction factors found in Table 310.15. V2. These correction factors adjust the allowable ampacity of the conductor based on the ambient temperature in the area where the conductor is installed. For example, if a conductor is installed in an area with an ambient temperature of 40 degrees Celsius, the allowable ampacity of the conductor must be multiplied by the correction factor for 40 degrees Celsius, which is typically less than 1.0. This correction ensures that the conductor is sized to handle the load current at the actual ambient temperature. Termination temperature ratings are the maximum temperature at which a conductor can be safely terminated at a circuit breaker, switch, or equipment terminal. Equipment is typically marked with a temperature rating, such as 60 degrees Celsius or 75 degrees Celsius. Conductors must be selected with a temperature rating that is equal to or greater than the termination temperature rating of the equipment. For example, if a circuit breaker is marked with a 75 degrees Celsius termination temperature rating, conductors with a 75 degrees Celsius or 90 degrees Celsius insulation rating may be used. The higher temperature rated conductors can be used to their 75 degrees Celsius ampacity. Common conductor types used for heat pump installations include copper and aluminum. Copper conductors have a higher conductivity than aluminum conductors, meaning they can carry more current for a given size. Aluminum conductors are less expensive than copper conductors, but they require larger sizes to carry the same amount of current. The NEC provides ampacity tables for both copper and aluminum conductors. The choice between copper and aluminum conductors depends on factors such as cost, ampacity requirements, and installation conditions. Grounding conductors are used to provide a low impedance path for fault current to return to the source, which helps to protect against electrical shock hazards. The NEC requires that all electrical equipment be properly grounded. Grounding conductors must be sized according to Table 250.122 of the NEC. The size of the grounding conductor depends on the size of the overcurrent protection device protecting the circuit. For example, if a circuit is protected by a 20 amp circuit breaker, the grounding conductor must be at least 12 AWG copper. Conduit is a protective enclosure for electrical conductors. The NEC requires that conductors be installed in conduit in certain locations, such as underground or in exposed locations where they are subject to physical damage. Common types of conduit include rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or IMT, and rigid polyvinyl chloride conduit, or PVC. The type of conduit used depends on the installation conditions and the requirements of the NEC. When pulling conductors through conduit, it is important to use a pulling lubricant to reduce friction and prevent damage to the conductors. The NEC also limits the number of conductors that can be installed in a conduit to prevent overheating. Proper conductor sizing is essential for safe and reliable operation of heat pumps. Incorrectly sized conductors can overheat, causing insulation damage, voltage drop, and even fire hazards. By following the guidelines in the NEC and consulting with a qualified electrician, you can ensure that conductors are properly sized for your heat pump installation. In addition to the NEC requirements, local codes and regulations may also apply to electrical installations. It is important to check with your local building department or electrical inspector to determine if there are any additional requirements that must be met. Regular inspection and maintenance of electrical systems can help to identify and correct potential problems before they become serious hazards. Check conductors for signs of damage or overheating and replace any damaged conductors immediately. Ensure that all connections are tight and free of corrosion. By taking these precautions, you can help to ensure the safe and reliable operation of your electrical system. Remember, electricity can be dangerous, so always take appropriate safety precautions when working with electrical equipment. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. When considering the installation of a heat pump, It's also important to understand the differences between various types of heat pumps, such as air source heat pumps and geothermal heat pumps. Air source heat pumps extract heat from the outside air, while geothermal heat pumps extract heat from the ground. Geothermal heat pumps are generally more efficient than air source heat pumps, but they are also more expensive to install. The choice between air source and geothermal heat pumps depends on factors such as climate, soil conditions, and budget. Ductwork is an important component of a heat pump system. The ductwork distributes heated or cooled air throughout the building. A properly designed or installed ductwork can reduce the efficiency of the heat pump and cause comfort problems. Ductwork should be properly sized, sealed, and insulated to minimize heat loss and air leakage. The location of the outdoor unit of a heat pump can also affect its performance. The outdoor unit should be located in a shaded area to prevent it from overheating in the summer. It should also be protected from wind and snow. The outdoor unit should be mounted on a level surface and should be accessible for maintenance. The thermostat controls the operation of the heat pump. The thermostat should be located in a central location in the building, away from drafts and direct sunlight. Programmable thermostats can be used to automatically adjust the temperature settings to save energy. Regular maintenance is essential for keeping a heat pump running efficiently. The air filter should be cleaned or replaced regularly to prevent dust and dirt from clogging the system. The outdoor unit should be cleaned of debris such as leaves and twigs. The refrigerant charge should be checked periodically to ensure that it is at the proper level. By following these maintenance tips, you can help to extend the life of your heat pump and keep it running efficiently. When selecting a heat pump, it is important to consider the energy efficiency rating. Heat pumps are rated by the Seasonal Energy Efficiency Ratio, or SEER, for cooling, and their Heating Seasonal Performance Factor, or HSPF, for heating. The higher the SEER and HSPF ratings, the more efficient the heat pump. Energy Star certified heat pumps meet strict energy efficiency guidelines set by the Environmental Protection Agency, or EPA. Installing an Energy Star certified heat pump can save you money on your energy bills. In addition to energy efficiency, it is also important to consider the size of the heat pump. The size of the heat pump should be matched to the size of the building. An undersized heat pump will not be able to adequately heat or cool the building, while an oversized heat pump will cycle on and off frequently, which can reduce its efficiency and shorten its lifespan. A qualified heating, ventilation, and air conditioning contractor can help you determine the correct size heat pump for your building. When installing a heat pump, it is important to follow all applicable codes and regulations. The installation should be performed by a qualified heating, ventilation, and air conditioning contractor. A properly installed heat pump will provide years of reliable and efficient service. In conclusion, understanding heat pump tonnage, amperage, and circuit conductor sizing is crucial for safe and efficient operation. Always consult with qualified professionals and adhere to the NEC and local codes to ensure proper installation.